Welcome to the lecture for section 11.6. We're going to learn a little bit more about graphing quadratic functions in this section. So what we're going to do in this section is learn how to convert a function of this form, that's the ax squared plus bx plus c form, into a function of this form, f of x is equal to a times x minus h all squared plus k. This is the form that we were working with in the previous section. Remember, this has a vertex at the point h comma k, which means it's been shifted h units to the right or left and k units up or down. And this a tells us if it has been stretched or shrunk and whether it opens up or down. So in order to tell all of that information, what we have to do is rewrite this quadratic function in the standard form into this form, which is vertex form. Okay, and you already have learned the basic techniques for how to do that because it is completing the square. We have two x's here, there's an x right here and an x here. We want to write them as a single x and a quantity all squared. Okay, so in order to do this, what we're going to do is it's slightly different than when we solved equations by completing the square, but not by much. So what we're going to do is first you would factor out any coefficient on the x squared. Now the coefficient in this case is 1, so there's nothing to factor out. But I am still going to group together the first two terms, leave a little bit of room there, and then move the last term off to the side. Now when we solved quadratic equations using completing the square, what we did was we moved this term over to the other side. Now instead of moving it over to the other side, I'm just kind of moving it off to the right side a little bit and giving myself a little space. Okay, then what we did to complete the square was we took this coefficient of x right there and we divided it by 2 and squared it. So negative 4 divided by 2 is negative 2, and negative 2 squared is 4. And that's the number that we're going to add in right here, is positive 4. Now, I just added 4, so in order to balance this out, I either have to add 4 to the other side or subtract 4 so that I'm not really making any changes to the equation. And just to keep everything simple, I'm going to put everything on the right side. So if you add 4, you also have to subtract 4 to keep from changing it. And now we can rewrite what's inside these parentheses as a perfect square. And it'll always be x plus this number, so x minus 2 in this case, quantity squared. And then these two numbers we can simplify to minus 9. So we have now rewritten this in this vertex form. Right? So we can tell where the vertex is just from looking at the equation. The vertex in this case is h comma k. Now notice a is 1, okay, but notice we have x minus h and this is x minus 2, which means h must be equal to 2. So the vertex is at 2, comma. Now it says plus k, so this is assuming this is a positive number here at the end, so we do have to include this negative sign with the k. So 2 comma negative 9 would be the vertex of this. Okay, the axis of symmetry is always x equals h so in this case it would be x equals 2. Okay, next let's find the intercepts if there are any. So let's find the y-intercept. Remember the y-intercept occurs where x equals 0, so we'll plug in 0 for x to get 4 minus 9 or negative 5. And it might have actually been easier to plug it into this version of the function because then it would have obviously been 0 minus 0 minus 5 or just minus 5. And for the x-intercept, that occurs where y equals 0. Now you have two choices here. You could I'm going to do this one both ways. You could set y equal to 0 in the original version of the function. So you could say 0 equals x squared minus 4x minus 5 and solve that. Or you could set 0 equal to f of x in this other version of it. And of course we'll get the same answer either way. If we use the one on the left here, let's see if this factors. It looks like if we do x minus 5 and x plus 1, that will factor out correctly. And so in this case, setting each factor equal to 0 and solving gives us x equals 5 and x equals negative 1. Now if we solve the other version, we could use a different technique. I would move the 9 over to the other side, and then I would take the square root of both sides. Now we're taking the square root of a variable squared on the right, so we need a plus or minus on the other side. So we have x equals positive 2 plus or minus 3. If you do 2 plus 3, you get 5, or 2 minus 3 is negative 1. So either way, so you get the same answers. And that's it for this one. We have enough information to graph it. Okay, so to graph it, we want to use all of this information we found. The fact that the vertex is at 2, negative 9, and the axis of symmetry is x equals 2. We have the y-intercept and we have the x-intercept. So let's begin by plotting all the points that we know that are on this function. So I'm going to scroll down a little bit. Okay, the vertex is at 2, negative 9. So on your graph, we'd go to 2, negative 9. Now this graph here only goes down to negative 7. So what you can do if that happens is, although I'm going to leave my x's as just going by ones, you don't have to label every single one. Okay, but what we can do is we can relabel the y-axis so that it goes by 2's. That way 9 would be included on the x-axis. So that would be negative 2, negative 4, negative 6, and so on. Now if you do this, just make sure you label your axis so that I know how you have changed it from being ones to something else. So now I can plot the point 2, negative 9 would be right there. Let's see, and the y-intercept is negative 5, so it crosses the y-axis here at negative 5. And the x-intercepts are 5 and negative 1, so it crosses the x-axis there and there. And we know it does open up because the leading coefficient is positive 1, which is positive, so it opens up. And there, oops, ignoring that little piece right there, there's a pretty accurate graph of our function that we got from knowing the vertex. And it's a good idea to label a couple points on here if it's not very obvious. Go ahead and label them. And that's it for this function. Okay, let's do the same thing for another function. Now this one is a little different in that it does have a coefficient in front of that x squared. So we do have to handle that this time. We do that by factoring it out of those first two terms. And I'm still going to put the constant way out here on the end. So I'm grouping together the first two terms, and you factor out whatever the coefficient of x squared is, you just factor that out. And then we go from here. So now we need to know, what do we add here to make it into a perfect square? Well, you take this coefficient, which is positive 1, divide it by 2, and square it, which gives us 1/4. So I'm going to add 1/4. Right there. Oops. Now, what I really added was not 1/4. Okay, if you were to expand this 2 out, you would find that now I have written 2x squared plus 2x plus 2/4 plus that 5. So what I really just added was a positive 2/4. So in order to balance out this equation, we need to subtract 2/4, or just 1/2. So over here, I'm going to put a minus 2/4. Be very careful about that. Anytime you factor out a coefficient, what you really have to subtract over here or add in order to balance it out is that coefficient times whatever you add in. Okay? Coming down here, now we can rewrite it with a perfect square. This will become x plus this number, 1/2, all squared. Then we have positive 5 minus 1/2. Positive 5 we could write as 10/2. 2/4 we can write as 1/2, and I'm doing that so that in the next step I can combine those because they'll have a common denominator. And that's the only thing left to do to simplify. So here's the function in vertex form. So now we can read off the vertex. H is, now remember in vertex form, back up here it says vertex form is a times x minus h all squared. So h, because we have a plus down here, h is actually equal to negative 1/2. And k, for k you do include that sign, which is positive 9/2. In case you're a little confused on where that negative came from on the 1/2, you could write this as 2 times x minus negative 1/2 all squared plus 9/2. If you write it like this, it becomes a little more clear that this is the a times x minus h squared plus k. So h is equivalent to that negative 1/2 because we have a minus and a minus here that we're comparing to. Okay, so that's it for the vertex. Next we need to find the intercepts. So for the y-intercept, we'll simply plug in 0 into the function. Let's just plug it into the original version of the function. Plugging it in up there means 0 plus 0 plus 5, so f of 0 is 5, that's the y-intercept. And then for the x-intercepts, we'll set it equal to 0 and solve. And I don't want to mess with factoring this, so I'm going to actually set my vertex form equal to 0. And solve this. So I'm going to move the 9/2 over. So we'll have negative 9/2 equals 2 times x plus 1/2 all squared. And we need to isolate the squared part. So I need to divide both sides by 2, or actually it's a little easier to just multiply both sides by 1/2 to get rid of that 2. So we get negative 9/4 equals x plus 1/2 all squared. Now at this point we can stop because, will anything squared ever equal a negative number? And the answer is no. There's no real solutions to this. Yes, there are imaginary solutions, but because there's no real solutions, that means there's going to be no x-intercepts. Imaginary solutions don't really correspond to anything on the graph of the function, so there's no point in finding those if you're just trying to graph. So it has no x-intercepts, but let's see, maybe we can tell a little bit more about it. The leading coefficient is positive, which does mean it will open upward. So that'll help us out a little. So why don't we plot what we know, and then if we need to find more points, which in this case we might because there are no x-intercepts, then we will. So we know the vertex is at negative 1/2, 9/2, so let's start by plotting that. That puts it right there. It opens upward, and its y-intercept is 5. Which is right here. So we only have 2 points and they're very close together. So yes, let's definitely plot a few extra points in this case. I'm going to rewrite the function down here at the bottom. It's 2x squared plus 2x plus 5. That's what f of x is. So if this happens to you, just plot more points until you can get a better graph. Let's plug in some numbers a little further away from this vertex here. So how about x equals 1? Let's just plug in and find f of 1. F of 1 would be 2 plus 5, so 9. It would be way up here. Okay, and because this is the vertex, actually this is enough points right here, because we know this right here is the axis of symmetry, which means we don't have to plug in -1 to know that it's going to mirror this point right here, so that it will also be 5. And if we plug in, let's see, a point 1.5 units away from the axis of symmetry, we should get 9. So f of -2 should also be 9. So the function's way up here. Looks about like that. Okay, and let's do one more example. Now this one has a negative leading coefficient. It doesn't matter, you work it the exact same way as we did the previous one in order to find or to rewrite it in vertex form. So we start by factoring out the leading coefficient from both of the first two terms, which leaves us with this. Leave a little space there, then put the +8. So what we add in is this number divided by 2 squared. So we're going to add 1. But I didn't really just add 1. What did I really add? I added -1 times 1. So I really just subtracted 1. So to balance it out, we need to add 1 over here on the right. Because really, if you distribute that negative, you'll find that I really added in -1. So we put a +1 to balance it out. And now we can rewrite it as a perfect square. Let's lift off my negative. It's the negative of x plus 1 all squared. Then 8 plus 1 is 9. So this one, we can read off the vertex. It's still h comma k. So the vertex is still, it's the opposite of the sign next to the x. So it's -1, comma positive 9. The axis of symmetry is at x equals -1. So there's the vertex, that's good. Now let's find the intercepts. So the y-intercept, if I plug in 0 into this function up here, I get 0 minus 0 plus 8, so the y-intercept is at 8. For the x-intercept, we need to set something equal to 0, either this version of f of x or this version. I'm going to set my vertex form equal to 0 because I think that will be easier to solve. Because if I add this term to both sides, then we'll have x plus 1 all squared equals 9. I can take the square root of both sides. So we have x plus 1 equals plus or minus 3. So x equals -1 plus or minus 3. Which is either, let's see, -1 plus 3 is 2, -1 minus 3 is -4. Okay, so let's plot all that information that we have. The vertex is at -1 comma 9. Again, I'm going to need to adjust the scale of this y-axis here. Let's go by 2's. But I believe I can still go by 1's and have no problem on my x-axis. Like I said, you don't have to label every single tick mark, just enough to get the pattern. So we have the vertex at -1 comma 9. So it's going to be right about there. The y-intercept is at 8. It's right there. X-intercepts are at 2 and -4. And I know that one is the vertex. So this must be the basic shape here. Okay, so that is how you can convert a quadratic function that's in standard form into vertex form. That's the most important thing from what we've done. But it's kind of a pain to do that every single time. So what we can do is do that, but on the general equation. And by doing this, what we'll do is we'll find a formula for the vertex so that we don't have to rewrite the whole thing in vertex form first. So what we're going to do is we're going to derive a formula for the vertex, that is a formula for h comma k, by completing the square on this function. So we're going to do exactly what we've done before, which is we started by factoring out the coefficient of a squared from the first two terms. By doing that, I need to factor an a out of b. Well, the only way to do that is to change it to b over a times x. That way, if I was to redistribute, I would have ax squared plus a times b over a times x. Those a's cancel and I do get ax squared plus bx. Okay. Now we need to figure out what to add right here. So you take the coefficient of x, divide by 2 and square it. b over a divided by 2 is equivalent to b over a times the reciprocal of 2, which is b over 2a. And then if we square it, we get b squared over 4a squared. So that's what I'm going to add in here. I'm adding in b squared over 4a squared. But what I really just added was this times a. So over here I need to subtract a times b squared over 4ac. Over 4a squared, I mean, to balance it out. And now I can rewrite what's in the parentheses as a perfect square. It is x plus this number, b over 2a, quantity squared, because that's the number I got before I squared it right here. Then over on the right, there's no need to simplify this much. The only thing I'm going to simplify is I'm going to cancel that a with one of those a's in the denominator. So we'll have minus b squared over 4a. Okay, and this is vertex form right here. Okay, vertex form, I'll write it beneath it. It says y equals a times x minus h all squared plus k. So h is equivalent to the negative of b over 2a. Oops, h equals negative b over 2a, because h corresponds to that right there. And k is all of this stuff. Now normally we don't, no one really memorizes this formula for k. Instead they just say, well, to get the y value of the vertex, why don't you just plug in the x value of the vertex into the original function. So k is usually just defined as f of negative b over 2a. Okay, so there's your shortcut formula for finding the vertex. So, in general down here, you can write it more cleanly. The graph of a function f of x equals ax squared plus bx plus c is a parabola with vertex negative b over 2a, comma f of negative b over 2a. And we can use that to very quickly find the vertex of a function. So let's do that for this function right here. Okay, we just have to identify what is a and b. A is the coefficient of x squared, and b is the coefficient of x, including the sign. So the vertex is h, comma, k, which is negative b over 2a, comma, f of negative b over 2a. Now negative b is the negative of negative 4, which is positive 4, over 2a, a is 1. Okay, so that's h. And then this, which simplifies to 2, so this k simplifies to f of 2. So we need to find what is f of 2. So we get to point 2, comma, let's see, f of 2, we just have to go over here and compute. F of 2 would be 2 squared minus 4 times 2 minus 5, which would be 4 minus 8 is negative 3 minus 5, so negative 8. So 2 comma negative 8 is the vertex for that. And you didn't have to rewrite the whole function in vertex form. You just used that shortcut formula. Negative b over 2a. So memorize that. Memorize the fact that h equals negative b over 2a. Okay, let's do one applied example. This is going to be the last example for the entire course. Alright, an object is thrown upward from the top of a cliff that is 100 feet high. its height in feet above the ground, that is the height of the object in feet above the ground, after t seconds is given by f of t equals negative 16t squared plus 10t plus 100. Find the maximum height of the object and the number of seconds it took for the object to reach its maximum height. Okay, so I'm going to draw a quick picture here to make sure you understand. Okay, so here you are, right there, that's you. You've got some object, let's just say it's a rock. You toss the object upward. Now you're already at 100 feet up. Here's the ground. So it's 100 feet from here to here. You toss the object upward and then it falls down. Okay? This function f of t gives you the height of the object in feet above the ground t seconds after you toss it. Okay, the goal is find the maximum height. Well, that would be that height right there. It's a high point. That's its high point. So how are we going to find its maximum height and the number of seconds it took to reach its maximum height? Okay, so there's two things we're finding here, the max height and the number of seconds it took to reach that. The max height, okay, is a y value of this function because f of t gives us height in feet above the ground. F of t is equal to height. So height is a y value here. The t values correspond to time. Well, they're like x values. So these t values correspond to time. The y values correspond to height on this function. So if you want to find the maximum height, that's equivalent to finding where this function has a maximum. So finding the max height is the equivalent of finding where the maximum of this function occurs. Now you know from all these previous examples that we've done that the vertex either corresponds to the maximum, right? That's the single highest point on the parabola, or if it opens upward, then the vertex corresponds to the minimum. Okay? The vertex always corresponds to either the max or the min of a quadratic function. Now this quadratic function is going to open which way? It'll be downwards because the leading coefficient, that of x squared, is negative. So this is going to open down. It opens down. So the maximum corresponds to its vertex. So what we need to find is the vertex of this equation. Well, we have a shortcut for that. The vertex occurs at h equals negative b over 2a, comma, f of h. Okay, negative b over 2a in this case is negative b would be negative 10 over 2a. A is negative 16. So we get 10. Actually, let's simplify before I do that. Before I multiply that out and then try to resimplify, let's just simplify it now. 10 over 2 is equivalent to 5 over 1. So we have 5/16. Now let's see, time is given in seconds, and that's an x value. That h is an x value, or a t value in this case. So that means that the max height occurs 5/16 of a second after you toss the object up. So we actually answered the second question first. The number of seconds it takes to reach its max height is 5/16 of a second. And now we can find the actual maximum height. The max height corresponds to a y value, that is k, the y value of the vertex. So k is equal to the max height. K is equivalent to f of h, which in this case is f of 5/16. So if we plug in 5/16 into the original function, we get negative 16 times 5/16 all squared plus 10 times 5/16 plus 100. So we have negative 16 times, this is 25 over 16 squared, plus, let's simplify this fraction over here, 10 over 16, I can take a 2 out of each to make that 5 over 8, which would give us 25 over 8. Now, I wrote this as 16 squared rather than figuring out what that is because now I can cancel that 16 with one of those 16s. So I have negative 25 over 16. Then I'm going to have plus 25/8 plus 100. So it actually would have made more sense to just leave this in terms of 16ths. So let's rewrite the second fraction here as 50 over 16. And then I need to rewrite 100 as something over 16. So if we multiply it by 16 over 16, we'll have 1600 over 16. Then adding those in the numerator, we have 1600 minus 25 plus 50 is equivalent to 1600 plus 25. So it'll be 16 plus 25, or 1625 divided by 16. Which, if you approximate that, that's approximately 101.563. So that's how many feet, that's the max height. So this person just barely tossed the rock up because it only went up 1 foot, well, 1.5 feet before it started to fall again. It only went up 1.5 feet because you were already at 100. Okay, so that is the max height of the object. That's it for this section. In fact, that's it for this chapter and the course. So I hope these videos have helped you to understand the material and helped you to learn how to solve these problems. I hope to see you again in a future course.